Yeah, camps on your own. Let's start off. Great. Last thing we are doing Kirchhoff's law. Others do keep your camps on. Let's go ahead with a question. Let's say we have a circuit here. This is C, this is C, this is B, and this is 2B. This is point A and this is point B, and we have a switch here. So this switch can, toggle between A and B. You can put the switch at A or you can put the switch at B. Both are same capacitance and batteries are V and 2V. So initially switch is connected to A. The first question. Find the charge distribution and the heat produced when the switch is flipped to B. So initially switches at A, you kept it there for a long time. So you kept the switch at B for some time. So you got some heat and new charges. Then what you did, again, find the charge distribution and the heat produced when the switch is flipped back to A. After bringing to point B, you brought it back to A again. Third, if you do this infinite times, so if you keep on switching, flipping the switch between A and B continuously, what are the final charges on the capacitor? Yeah, let's get them. Others do keep your cams on. How do we start? First draw the circuit, when it is connected to A, find the charges. Then you switch it to B, draw the circuit. First draw the circuit always. And people who didn't give the test, right, please stay back after the class. If you are not interested in giving the test or you can't give the test, I think then do let me know. You need not sit in this batch anymore. So initially this was the circuit. This is V, C, and C. Initially both the capacitors are empty, so C equivalent is C by 2. So this will be CV by 2. This will be minus CV by 2. This will be CV by 2, and this will be minus CV by 2. This was the switch at point A. This 2-volt battery is useless. It is just hanging in air. It's not connected to anyone. Now if you flip the switch, this is how the circuit will become. This is 2V, this is V, this is C. This capacitor is hanging in air. See, once you disconnect a capacitor from a battery, right, the charges will get stuck there. So this charge will still remain CV by 2. This will remain minus CV by 2. Now on this capacitor, charges won't remain same. So we need to find those charges. Let Q charge go from the battery. Isn't that how we start anytime? If you're connecting a capacitor with a charge already to a battery, this is how you start. Let charge Q go from the battery. Then initially how much charge you have on this plate? Minus CV by 2. Now you will have Q minus CV by 2. Agreed? On that plate you had minus CV by 2. Now you sent an additional small q. Now apply Kirchhoff's law in this loop. You're going to the battery, 2V. You're going to the capacitor, Q minus CV by 2 by C, and minus V equal to 0. This guy would be CV, Q is equal to 3CV by 2. So this much charge goes through the battery. Now what is work done by the battery? Now be careful here. There are two batteries here. One battery is giving charge and one battery is absorbing charge. So the work done will be Q into 2V minus Q into V. The 2-volt battery is getting discharged and the V-volt battery is getting charged up. It is absorbing energy. So the work done will be QV, which is 3CV square by 2. This is the work done by the battery. Clear with this? And the final charges on the capacitor would look like this. So this plate has become CV. This plate is minus CV. This plate is CV by 2 still, and this is minus CV by 2. These are your final charges, everyone. When the switches flip to B. And what is the heat produced? Heat produced is nothing but initial energy, which you can find, the charges, plus work done by battery, that also we found, minus final energy, the final energy in the capacitor. Use Q square by 2C. Is that clear, everyone? And then you're done, you'll get the heat produced. Clear with this? This is the first part. Now, what is the second part? Now, again, you took the switch and flipped it back to A now. Now, can you find the new charges and the new heat produced? Now you get it. I'll give you 2 minutes. So the final part of this circuit will be the initial for the next question. Now the switch is flipped back again to point A. Find the heat produced. this final circuit will be the initial circuit. When you flip it back, you'll get again a new circuit. You always have to keep drawing the new one. So this would be the initial circuit now. Now, the catch in the question is the two capacitors are not in series. Did you guys realize that? Just because they're side by side, they're not in series, they don't have same charge. Don't take them in series. You could have done that initially. Initially, did that. You know why? Initially, capacitors were empty. So they had same charge. So I could take them in series. It worked out. You can't do this now. Once you flip the switch, you messed up the whole thing. Then how do we start? Same story. Let charge Q go from a battery. Keep it simple. The reason why I like to do like this is because if I know how much charge is going through the battery, I can find work done by battery. So this would be a better one. So Q will flow, Q will come back to the battery. Always Q has to come back to the battery. So this plate, whichever plate the charge touches, I will assume it as a positive plate. Q minus CV. The signs will take care of themselves. This guy will be Q plus CV by 2. This 2-volt battery is useless. Apply Kirchhoff's law. V Q minus CV by C minus Q plus CV by 2 by C. This will be V minus Q by C plus V minus Q by C minus V by 2. We get Q is equal to 3CV by 4. So this much charge goes through the battery. Then the final charges will look like this. Kind of expected. That is the actually a negative plate. So this guy is the positive plate, CV by 4. This was minus CV by 4. This was 5CV by 4. This is minus 5CV by 4. There. These are not in series. The charges got messed up. These are your final charge distributions, everyone. And there's only one battery, so work done by the battery will be 3CV squared by 4. Same story, heat produced will be initial energy. So find the energy in these two capacitors, plus work done by battery and the final energy in the capacitors, and you're done. Clear with this? Now, if I do this one or two more times, you will observe you'll find a sequence actually. And then when you put n tends to infinity, you'll get this thing. But there's a much better way to do this. Now look at the third question. If I keep on flipping the switch between A and B continuously, what is the final charge? Think, I'll give you a minute. How do you approach that one? One way to do this is now do it one or two more times, you'll find a sequence there. So if you want to find a sequence, you can take this as C1 and C2 and try, you'll get a sequence. You'll get something like C1 by C1 plus C2 whole square, whole cube, whole power 4. So that number will just keep on piling up like that. You'll get something of that sort. But we don't want to do all that. Eventually charge becomes constant. So what is that final charge? So without solving all that, how can we figure out? Think, take a minute or so. Then let me tell you something. Let me make this sentence. Tell me what does that mean? Finally, the charges have become constant. Just look at that word there. That means if you keep the switch at A or if you keep the switch at B, the charges are not going to change. Eventually, if the charges have become constant, if you flip the switch, the charges are not going to change. Isn't that what you're saying? Whether you put the switch at A or switch at B, it doesn't matter. Whether you put the switch at A or whether you put the switch at B, the charges are not going to change. What does that mean? The switch will think A and B are identical. That means A and B ka potential has become same. That means you can just join A and B. And then your circuit becomes like this, isn't it? Your circuit becomes like this. So if you can find the charges for this system, wouldn't that be the charges at infinity also? You get in the logic? If the potential at A and B has become same, you can just join them into a single wire. So it doesn't matter where you connect the switch. Now the whole thing will look like as if this thing is joined completely here.
Sir,
Yeah.
so could you explain once again why the potential is same at infinity?
See, so after infinite flips, charges become constant. That means it doesn't matter whether you keep the switch at A or switch at B. There will be no redistribution of charges. Charges are not getting redistributed anymore. Why are the charges not getting redistributed? Because at A and B have same potential. The switch will think nothing changed. So we can say VA is equal to VB. If VA is equal to VB, you can just join them. To V, C, and C. Let this charge be Q1. Let this charge be Q2. Apply Kirchhoff's law here. Apply Kirchhoff's law here. This will be 2V minus Q1 by C. So Q1 will be 2CV. 2V minus Q2 by C minus V. Q2 is equal to CV. These will be your final charges. Is that making sense? Because if the potential had not been same, the charges would have continuously kept on redistributing. The switch could not figure out who is A and who is B. That is the meaning of it. Switch didn't care whether you keep it at A or B, the answers will remain same. Clear with this question, everyone? It's a decent paragraph. So the main catch in the question that when you start flipping the switches, the capacitors won't be in series anymore. Most people don't realize that. They think it is in still series and goof up. Be careful with that. All clear? Any doubts on this? Next one. This is a decent mains level question. They do ask this thing. Till now, if you see, I was giving you charge on the capacitors. They'll say like this. We have a capacitor charged to potential V1. So a capacitor of C1 is charged to a potential V1. Another capacitor C2 charged to potential V2. This is also good result to remember. Then case one, what you did, you connected them in same polarity. Meaning this is plus, minus, C1 and C2. Case 2, you connected them in reverse polarity. Plus, minus, plus. So the negative plate is connected to the positive plate. Find the new potential difference. So initially the voltages were V1 and V2. If you connect them in same polarity and opposite polarity, find the new potential difference across the capacitors. This is a standard mains level question. Let's get this. I hope the question was clear. You took two capacitors and connected their positive terminals and negative terminals. You took two capacitors and connected the positive to negative and negative to positive. The same polarity and reverse polarity. Find the new potential difference after connecting them. Try. You got 2 minutes. So instead of giving charge, sometimes they'll give you potentials. How do we get this? Same story. Let charge Q go from the any one capacitor. If charge Q flows away from here, then this guy will become C1 V1 minus Q. This guy will become C2 V2 plus Q. So the potential difference between them will be charge C1 V1 minus Q by C1, C2 V2 minus Q by C2, because they are in, they have same potential difference. So from here you can find V1 Q by C1 is equal to V2 minus Q by C2. So we get VQ is equal to V1 C1 V2 plus Q. V1 minus V2, that will be 1 by C1 C2, so C1 C2 by C1 plus C2. This much charge flows through this. So take this Q and put it back in any one of the function. This is the same thing we do even if you have three capacitors. If you substitute back, you will get V1 minus Q by C1. So V1 minus V2 by C1 C2 by C1 plus C2 by C1. So I'm taking this and putting in this guy. C1 C1 cancels off. You will end up with C1 V1 plus C2 V2 by C1 plus C2. Yeah, decent result. You can remember this. And how to do for the second one? Simply put V2 is equal to minus V2, right? If you flip V2 as minus V2, the polarity is reversed. The formula will become C1 V1 minus C2 V2. So you can just remember the result that way. So the new potential difference will be C1 V1 plus C2 V2 by C1 plus C2. There's no need to do the second one. When you're putting in reverse polarity, you're saying I'm putting in reverse potential. So V2 becomes minus V1, minus V2. C1 minus V1 by C1 plus. Is this clear, everyone? Mostly a mains or a bits level question. Your seniors are saying this time bits came tough. Few people did score. I think highest so far is 323 out of 390. So that way, couldn't we just take the final potential V and then write C1 V1 plus C2 V2 is. Why are you doing that? But you can do that. Yeah, you can do that also. Works, Raditya. But again, I wanted to keep the process same. If you have 3 capacitors, you'll be gone. This scale you can do. All got this? That is one. Next thing. Dielectric slabs. Now, if you remember in the beginning, we discussed whenever you want to increase the capacitance, A epsilon by D, increasing the area was a bad idea. You need very huge areas. Decreasing the distance was a bad idea because there's a dielectric breakdown. You get sparks. So the only option left is changing the material between them. The capacitance in vacuum is given by A epsilon by D. So if you take a capacitor and if you fill up the space with a medium, so a dielectric slab is nothing but an insulator basically. You don't want to put a conductor between them. If you put a conductor, the plates will get connected, shorted, and the charge will start flowing. So a dielectric slab is an insulator which does not let any charge flow between the plates. So this K is called dielectric constant now. This is not anything new. We have done this in electrostatics. Remember epsilon R, relative permittivity? For some reason, they started calling it K here. We are already lack of symbols. So it is the same thing as epsilon R. There is no difference between K and epsilon R. This is relative permittivity. You know which one I'm talking about? When two charges are placed in a medium, the force will be Q1, Q2 by 4 pi epsilon medium into R square. That epsilon medium is given by, so epsilon relative is epsilon medium by epsilon vacuum. This is only K. So it is the same stuff. So if you put a medium between the plates, the capacitance will become A epsilon medium by D. This is epsilon R, or let me write as K, A epsilon naught by D. So this becomes K times C vacuum. There, by introducing a material, you can increase the capacitance. This thing also has few advantages actually. Most of the times people use zinc sulfide. Zinc sulfide ka K value is around 8.3 or something. So basically you can use electrolysis and you can deposit a thin layer, between the plates. It's like a sandwich. The thinner the layer, the better. You can decrease the distance. So what is the advantage of this thing? One, K value is great, so you get more capacitance. Second, think of this way. If I just put two plates like this without anything in the middle, there is a high chance the distance will change. Isn't it? The plates cut distance will get messed up. The plates will not have enough strength to withstand the forces. So this thing provides mechanical strength. So this also makes the plate cut distance, between them constant. And it also gives some kind of a strength to the whole capacitor. If you apply some force or something, it just doesn't, collapse. So this thing actually has a lot of advantages putting a material. So even if you don't need, people prefer to put a material for other purposes. And if you take conductors, I told you what is epsilon R. Epsilon R tells you how difficult it is for the field to transmit. Now tell me, through a conductor can field go? Through a conductor field cannot go. So epsilon is the resistance for the field. So a conductor will have how much resistance? Infinity. So K value simply tells you how difficult it is for the field to travel through. For vacuum, K is equal to 1, least resistance. As the material is there, for conductors, you will get infinite resistance. None of the field lines will pass through the conducting slab. Is this clear, everyone? So this is the main thing that happens when you put a dielectric slab. Capacitance becomes K into C. That's it. As simple as that. But let's see what exactly happens inside a dielectric slab. Any doubt so far? All clear with this page? Aditya, clear? Push. Next thing. So when you keep this inside, so on this plate, if you have a positive charge, let's call it sigma, or let's call it Q. This is minus Q. If you guys remember, we did this in Gauss law. If you keep a conductor between this, what would happen? The electric field due to these outside charges will pull the free electrons towards the positive charge, and they will induce a negative charge and a positive charge. And these induced charges will start fighting with the external field, right? And in a conductor, you have a lot of free electrons. So these electrons will keep on moving till they become strong enough to cancel the outside field. But in a dielectric slab, which is an insulator, you don't have an endless supply of electrons. You have very few electrons actually. So this causes something. So instead of the electrons moving completely, they get stuck, they get dipoles. Do you guys know what is a free electron? Did you study something like that in chemistry? I'll just give a little context. For example, let's say if you take two atoms like sodium, 1s, 2s, 2p, and 3s. So when you take a sodium crystal, right, it forms a lattice. So you have a lot of sodiums in this 1s, 2s, and 3s. Let's say, for example, the 3s orbital is a common orbital. Matlab, the 3s of this sodium and 3s of that sodium, they overlap a bit. Now see what happens. There is one free electron in 3s which is roaming around in the sodium. Because the orbits are overlapping, the energy level is almost same. So what will happen? This electron can jump into this orbit also. It can jump into the other orbit also. It can jump from here to here. You're getting this electron, there's no one to stop. It will keep on jumping from one sodium to another sodium. So this electron is not bounded by one atom. It is free to move within the lattice. It can't get out of the lattice, but within the lattice, it can move however it wants. This electron is called a free electron. Same thing, if you try to do this with sodium, let's say carbon. Now the problem with carbon is the last electron you have is in the 2p orbital, but the common orbit is 3s. So these electrons have to jump first to 3s and then only they can move around, right? The free electron to move around, it is in 2p. First, the electron in the 2p should give some energy for it to jump to 3s. Once it reaches 3s, then it is free to move between different orbits because 3s is the common orbital for all of them. That's why carbon behaves like an insulator. You need to provide energy to create free electrons. So any electron in the 3s orbit here will be a free electron. Is that making sense? Sodium has a free electron already sitting for you. But for atoms like carbon and everything, you need to provide energy to excite electrons from the lower orbit to higher orbit to create free electrons. Is that making sense? The bigger the energy, the more it behaves like an insulator. Yeah, graphite is an exception, but if you just take a carbon thing like a diamond or something, it's an insulator. Clear with this? I hope you know why graphite is an exception. You will learn in chemistry. Anyway, so we don't have enough free electrons. So instead of getting completely separated out, you will get some dipoles. So if you don't have a free electron, but if you apply field, what will happen? They will pulled apart, you'll get a dipole. Remember, we did that in dielectric breakdown. So in a dielectric slab, which is an insulator, we don't have enough free electrons. The reason the conductor will always have zero field is because you have so many free electrons the moment you apply a field, right, they'll all just, there are so many, they'll just, start inducing and they'll fight back. Right, in this case, you don't have enough free electrons to induce enough charge. So the concentration is negligible. So electrons which can freely move across the lattice. So they're not bounded by a single atom. So this electric field creates dipoles. By moving the electron and the nucleus apart. You start getting dipoles. So you can actually think of an analogy. Huh? So why, now see, capacitance became Kc, so energy stored is half kCv square. That means you have increased the capacity of the system to store more energy. So if I had to give an analogy, think of like this. These dipoles will start acting like small springs, isn't it? When you separate minus q and plus q, there's a small energy stored between them. So the additional energy that you're creating in the system is because of the small dipoles, which are acting like small springs there. So when the minus and plus combine, you get energy back again. You're getting? So the reason why it can store more energy than an empty space is because these dipoles are being separated. When this plus or minus combine back, you get some more energy released. So you have made that system store a little more energy than just a normal space. Making sense? Kind of. You can think of a logic like that. Why putting a dielectric increases your capacity? Previously, you're just storing the whole thing in space, vacuum. Now you're storing it within the dipoles also. Now, this thing is important. So now I want to find, chalo, you can't induce equal and opposite charges, then how much do you induce? So consider the two plates. Let this charge be sigma. This is minus sigma. And let's say you have a dielectric slab. So this will induce, let's say, minus sigma I, and this will induce sigma I. Remember, only for conductors, you will induce equal and opposite charge. If you put a dielectric slab, there's no guarantee. This will be some other charge. Now, inside there are two fields fighting. One is the field due to the plate, and another field is the field due to the induced charges. In case of a conductor, both are equal. So the induced charges will try to oppose, but they're not strong enough. So the field due to the plates, remember there are two plates, sigma by 2 epsilon into 2. So sigma by epsilon. The field due to the induced charges is sigma induced by epsilon. And you guys remember in Coulomb's law, if you take two charges and put them in a medium, what happens to the force? 1 by k times. So from the field also becomes 1 by k times. From Coulomb's law, the field inside a medium, this is a good result. You should definitely remember this. Field inside the medium becomes 1 by k times. Meaning, if you take a dielectric slab, if outside the field is E, the moment you enter you inside, your field ka value becomes E by K. It decreases. Once you come out, again it becomes E. You're getting this? Why is the field decreasing? Because of the induced charges. And why it won't affect outside? Think about it. If this is minus and this is plus, what is the field outside? Both will cancel, right? So that slab will not create any field outside the slab. They will create the field only inside the slab. Do you guys agree with that? See, this is minus sigma I, this is plus sigma I. In the middle, what is the field? Negative is pulling, positive is pushing. Both are in same direction. But if you look at outside, the positive is pushing and negative is attracting. Here, attracting, pushing. Can you see outsides become zero? The slab will not create any field outside the slab. Only between the slab it creates field. So that is the reason outside the field doesn't get affected. So from this logic, if you take E inside, this will be the field due to the plate plus field due to the induced charges. This will be sigma by K times epsilon. This will be sigma by epsilon. This will be minus sigma induced by epsilon. From here we get sigma induced will be sigma into 1 minus 1 by K. Pretty good result to remember. This will be the induced charges. You don't induce equal and opposite charge. If you put a dielectric slab in front of a metal plate, you'll get sigma into 1 minus 1 by K. For conductors, K is infinity. Sigma induced will be sigma there. For conductors, you'll induce equal and opposite charge, but for a dielectric slab, you'll get only sigma into 1 minus 1 by K. Is this clear, everyone? Please have a look at this page. That is quite an important formula. You can note it down in case you want. Clear? No. That means if you take these two plates, this is plus Q, this is minus Q. So this will be minus Q induced and this will be plus Q induced. So just remember that. So Q induced will be Q into 1 minus 1 by K. Then we define also something called polarization. And here, if the field is E, then here the field is E by K. We define something called polarization. You must have heard this in chemistry, which is nothing but dipole moment per unit volume. What is dipole moment? Charge induced into distance, and what is volume? A into D. This is nothing but sigma I. So the induced charge is nothing but the polarization. So there. Have a look at that. Got this? Let's see a question. Yeah, primarily in a slab, these are the main things. One, the capacitance becomes Kc. Second thing, the induced charge is sigma into 1 minus K, and the field inside is E by K. These are the three main points you need to know. So we have two plates here, A and B. Let's say this charge is Q, and this charge is 2Q. A and B are conductors. Then what you did, you took the plate A with same charge Q, but this time you went and kept a dielectric slab. K is equal to 3. This is a neutral dielectric. So find the ratio of force between inner surfaces, not the plates. मतलब this space and this space का बीच में whatever is the force between inner surfaces of AB and AC. So find the force between AC ka inner surfaces and find the force between AB ka inner surfaces. Is the question clear? How do we approach this? Three is to one. Try. I'll give you a minute more. I just want the forces between the inner surfaces. 3 is to 1. Weird. Let's see. In the first case, when you take A and B, remember both are conductors. How the charge is distributed? Total by 2. So this will be 3q by 2. This will be 3q by 2. This will be minus q by 2, and this will be q by 2. The force between surfaces will be charge on any one surface into field due to the other surface. Don't use k, q, and q by d square. These are point charges. So this will be minus q by 2. And the field will be q by 2 area, that's your sigma, by 2 epsilon. This is minus q square by 8a epsilon. This is the force between the inner surfaces. Got this? Now, when you take a dielectric slab, this thing is charge q. So this will split q by 2 because that is neutral, right? This is neutral. This is charge 0. So for a conductor, it is still valid. The outside charge is total by 2. And what will be the Q induced? Q induced will be Q by 2, the facing plate, into 1 minus 1 by K. K is 3. So if you put 1 by 3, 2 by 3, you'll get Q by 3. So this guy induces a charge of minus Q by 3 here, and this thing will be plus Q by 3. All the charge won't come inside, na? Even for a conductor, half will distribute because the outside charge is total by 2. Dielectric is neutral. This guy is Q, and they're done. And then, so this force between A and C will be Q by 2 into the field due to that guy will be minus Q by 3 area, that is sigma by 2 epsilon. This is minus Q square by 12A epsilon. Get the ratio. This would be FAB by FAC 12 by 8, 3:2. Aditya got it. Aditya Adalkar, he got it. Is this clear, everyone? It's a good one. Putting a dielectric slab. Conductors are fine. Dielectric slab is a little different. So there, you mixed up Gauss law with dielectric slabs. All clear with this? In case you're wondering, how did I got Q by 2, Q by 2? See, I'll give you a proof very fast. Take a point inside. Inside a conductor, what is the field? 0, right? This charge and this charge, whatever is the charge, they'll create equal and opposite fields. So these two fields will cancel. You're getting it? So this charge and this charge must be equal if the field inside is 0, isn't it? That's why it should be half and half. You can prove like that also. Is that making sense? Why it should be Q by 2, Q by 2? Because the dielectric slab is neutral, it will not create any field. So this conductor should have equal charges on both the sides to create a 0 field in the center. Clear, Ansh? Adi? Clear? Devansh? Niharika? Vivan? Vignajit? Next one. I hope you guys remember this. So we have two parallel plates. The upper half is filled with K. Where we do these kind of problems? The lower half is filled with 2K. Heat transfer. This area is A by 2, this area is A by 2, and this distance is D. Find C equivalent. In heat transfer, I used to ask you thermal resistance. Do you guys remember the B part? There's a trap. Get them. I'll give 2 minutes. These things are standard stuff. Same thing. You know how to do this. First was easy. What you do? Treat them as two capacitors. The upper one and the lower one. And this will be C1, which is area A by 2. Epsilon ka place mein K epsilon. Distance is D. And this is C2. Area is A by 2. This would be 2k epsilon by d. Both are in parallel. So C equivalent is C1 plus C2. 3k epsilon by 2d. Anyone remember how to do the B part? Try. I'll give you a minute. 11 by 5. I don't think 11 by 5 आएगा. I don't remember the answer. 17 by 12. Maybe. I don't think it is 11 by 5. That I'm sure. 17 by 12 could be. I vaguely remember the answer. In case you forgot this concept, you should go back to heat transfer. This we did in pretty detailed if you remember. Remember what is the concept? The upper interface and the lower interface are not identical. Since the upper and the lower interface are not identical, they won't have same potential. Therefore, they won't have the same potential difference. You're getting this? So you have to take them as you can't take them in parallel. This is how the system looks. So here this point will be some potential V1. This will be potential V2. The upper half and the lower half do not have same potential. They're not symmetrical, right? The upper half, lower half don't look identical. So this guy will be Kc, this guy will be 2Kc, this guy will be 3Kc, this guy will be Kc. Where C is nothing but area became half, epsilon distance also became half. So epsilon by d. Solve that, you will get the answer. Yeah, people are getting 17 by 12 Kc. So could be right. Check it out. All got this? Pretty good one. We encountered the same thing in heat transfer. So you know how to make them in parallel? If at all you want to make them parallel, then you put 3 plates. You put a plate in the middle. Now fill up the space with a dielectric here, dielectric here. Now what happens, right? This metal plate in the middle, because it's a metal plate, the potential becomes same. Now they're in parallel. Got it? If you don't put a plate there, then they're not in parallel. Put a plate, then parallel. I think this kind of question came in some 2019 or something. Medical में आया था, NEET में. So they gave the answer when there is a plate. So there's no plate. So when you go online and check the answers, you'll always find the answer for that question. So be careful with that in case you see it somewhere. Let's see something better this way. Then if this is the scenario, let's say, what if I take 2 parallel plates? Square plate side A. And you fill the dielectric like this, like a sandwich. This is 2K. Able to visualize how it is? It's like a triangular wedge. And the distance between them is D. Find C equivalent. How will you do this? How do we approach this? Let me give an idea how to choose an element. So at a distance x, choose a thin slice dx. So this will be like a thin capacitor whose area will be A into dx. In this thin capacitor, if you take this angle as theta, so this part is filled with K and the upper part is filled with 2K, isn't it? So this guy and this guy will act like two capacitors in series. Is that making sense? And like this, if you take every rectangular strip, all these rectangular strips are in parallel. Is that making sense? Now can you try? Try. I'll give you a minute or two. So you have to take thin vertical strips. All the strips are in parallel because they have the same potential difference. Right, Aditya. You remember the answer? You did it. Can you do it for K1, K2? Send me the answer for that. So when you take this slice here, this part will be the red one. This will be x tan theta. So that will be the distance between the red plates. This will be d minus x tan theta. And this will be the area ADX. So I can treat them as two capacitors in series. This is DC1 and this is DC2. DC1 will be area ADX 2K epsilon, that is your medium, A epsilon by distance d minus x tan theta. DC2 will be ADX K epsilon by d tan theta. And what is tan theta? This distance is d. Tan theta is d by a. हाँ आदित्य, in your answer if you put k1 is equal to k2, 0 नहीं आ रहा है और infinity कुछ तो आ रहा है. K1 is equal to k2, I should get back a epsilon by d into k, na? So these two are in series. So 1 by dc equivalent will be 1 by dc1 plus 1 by dc2. There, you have to reverse them and keep them there. You will get 1 by, take out a epsilon k dx common, you will be end up with d minus x tan theta by 2 plus x tan theta. You can do the calculations. When you reverse this, you will get dc is equal to A epsilon k dx by 2. This is small a, yeah? This is small a. By d plus x tan theta. C1 series, C equivalent, integrate this to a epsilon k, this dx by d plus x tan theta. Limits will go from 0 to a. Tan theta comes out. This will turn out to be 2f square epsilon k by d. You'll get ln 2. You can check it out. 1 plus d x tan theta integration is what? 1 by tan theta ln d plus x tan theta. Limits will go from 0 to a. And put tan theta is equal to d by a. I skipped a lot of steps here. You can integrate and check out your answer. But did you get the process here? I think if you got till here, your job's done. So the main idea is this. You take a vertical element. Why can't you take a horizontal element? If I take a horizontal element, do you think within this element, is the potential same everywhere here? That's the problem. That entire face will have different potential everywhere on this surface. Don't know what to do with that. So when you take vertical, I know the same charge will flow, and then you can take the vertical strips to be rectangles to be in parallel. Is this clear, everyone? If I put K1, K2, same thing. Yeah, the calculations will be a little more bad. But you would get it. The process would be the same. Any doubts on how did we choose the elements? Anything that you're not clear? All clear? Next thing. Ignoring the charge due to different potential. What different potential? What are you talking about?
So you said across that horizontal strip there would be different potential, right? So
you can't do anything with that, right? They're not all in, not in parallel. That one single strip, you can't find the capacitance.
okay.
Because within that single strip, again, each piece is having a different potential. Normally, when you take a parallel plate, you prefer to have same potential difference, right? It won't work for that. This is another good one. I can combine 2-3 questions together in this. You have two parallel plates. This would be a decent more than one choice or a paragraph. This is voltage V. This is grounded. We have a dielectric slab here, K. We also have a conducting slab in the middle. So someone kept a conducting slab and a dielectric slab. This is x is equal to 0, x is equal to d, x is equal to 2d, x is equal to 3d, x is equal to 4d, and this plate is x is equal to 5d. So everything the distance is d. So the dielectric ka thickness is d, conducting slab ka thickness is d. Distance between the plates is 5d. First question, find C equivalent. Second question, plot electric field versus x graph. So in this region, how will the electric field change with x coordinate? Third, plot potential versus x graph. As you go from left to right, how will the potential change? We know this is grounded, so 0. This is V. So as you go from left to right, potential goes from V to 0. How will it change in a graph? There, get all these three. The first one is a pretty good mains question. The graphs are also good. Each one could be a decent question at mains also. Advanced, I'll put this as a more than one choice question. Advanced will do actually more deadly things. We'll see that in the next chapter. I will say this plate is oscillating in SHM. ये ना मैकेनिक्स तो है, बहुत दिन हो गए ना एसएचएम देख के. Let's get this. Let's see. What's the catch? Tell me one thing. Let me ask you this question. How did you even start the whole thing as a capacitor? What is a capacitor? Capacitor is a space where electric field lines are stored. So my question is, does conductor have any field lines inside? So you can just remove that space, right? So if you put a conducting slab between two plates, you can just ignore that space. So that's the first thing. Since the field inside a conductor is zero, you can just assume as if there is nothing there. That space is gone completely. We can ignore the space. Occupied by conductor. Means your new capacitor becomes like this. So we only have a dielectric K. Let this distance be X. Let this distance be D. And the baki ka distance will be 4D, 3D minus X. You're getting it? So you can assume the total distance is 4D now. Instead of 5D, you can treat the whole capacitor to be 4D. Got this? So this can be treated as three capacitors. since I didn't tell you where I kept the slab, meaning I know that also, but I wanted to show you something here. So let's assume this, the dielectric is placed anywhere randomly. This would be X. This was the dielectric, which was D. I'll do one thing, but I'll give a more generalized result. Let this be T. Four D minus T minus X. All are in series, so 1 by C equivalent will be A epsilon by X plus A epsilon K times T plus A epsilon 4D minus T minus X. You'll notice X will cancel. So 4D minus T by A epsilon plus T by A epsilon K. So from here you get VC equivalent will be A epsilon by 4D minus T plus T by K. Independent of X, it doesn't matter where you keep the slab, you'll get the same answer. And if you have a conductor, just ignore that space. Clear with this? So in our question, T is also equal to D, so just substitute there, you would have got the answer. But this would be a proper mains level question. A slab is placed between the parallel plates, find the new capacitance. Clear, everyone? So two things in this question. You can keep the slab wherever you want, it's not going to affect. Conductor is useless, just remove that space D and the new distance becomes 4D. Question is not over. Can you plot the electric field and potential versus X? Get that. That would be the main question. Try, I'll give you 2 minutes. See, do you guys remember what is the field between the plates? Field between the plates is simply potential difference by distance between them. It doesn't matter if you have a slab. The field is simply V by D. And remember, ignore the conductor. So it is actually V by 4D. Whether you have a slab, you don't have a slab, it doesn't matter. Because remember I told you the slab ka field is not going to affect anything outside. Right? So here if the field is E, the field here is going to be E by K. Again here it is going to be E. Inside the conductor field is 0 and here it is again going to be. Agreed? So the field is constant. These are infinite plates. So how will the graph look like? If you plot E versus X graph, initially the field was constant up to D, then it decreases. Inside the dielectric field decreases E by K. Then again it increases. Then inside the conductor it becomes 0. Then again it increases back to the value. This is how the graph will look like for field versus X. And then we know field is nothing but minus dV by dx. That means negative of a slope. So in a Vx graph, the slope is nothing but field. So using this information, if you try to plot a Vx graph, the slopes must be field. You can clearly see initially the potential starts at V, it decreases. Then it decreases, but decreases at a slower rate because inside a dielectric the field is less. Then again it decreases. Then it becomes constant inside a conductor. Then again it decreases. If you actually see the angles, if this is alpha, this is alpha, this is alpha, this will be beta. Where tan alpha is the field here, which will be E. Tan beta will be E by K. And inside the conductor, the potential becomes same. It's an equipotential region. So it will be a horizontal line. We'll have three parallel lines, and the field and potential inside our slab will be at a slow, at a lesser slope. This is how the graph looks. Are the graphs clear, everyone? So the potential is continuously decreasing. In the direction of the field, potential decreases. And the slope in a Vx graph is the field. Any doubts on this thing? It's a pretty good question. The graphs, the C equivalent. Puraja? Clear? Aditya? Clear? Ahana? Adi? Vihan? Vivan? Clear with this? Vihan, clear. Next one. This, we have done something like this before. We have a capacitor. We have a battery, V and C. Case 1, battery is removed. Case 2, battery is present. So you removed the battery here, you kept the battery here. Then what you did, a dielectric slab is introduced between them. So in the first case, you remove the battery and then you put a dielectric. Second case, you keep the battery and then you put a dielectric K. Do you guys remember this question we did? With the battery, without the battery, distance between the plates was doubled. So case 1, case 2. Find the new charge, new capacitance, new voltage, new field, force between the plates, energy, and energy density. So options will be like same, k times, 1 by k times, k square times, something of that sort. Get them both. You got 3-4 minutes. Try case 1, I'll give you 2 minutes for that. Then I'll give you time for case 2 again. Right. What happens if you remove the battery? Charge remains constant. What happens if you keep the battery? Voltage remains constant. नहीं Aditya, you goofed up the energy density and you got the force का answer lucky. Let's see the case one. If you remove the battery, charge remains constant. There are a few things. So charge remains Q, same. Capacitance becomes Kc. The voltage is Q by C, so this becomes 1 by K times. Field is simply V by D. Distance is same. Voltages became 1 by K. So field also becomes 1 by K times. Now here see, force is a little thing. Force is Q square by 2A epsilon. You need to see something here. Do you guys remember this statement? The force between two charges is independent of the medium. If this guy is plus Q and this guy is minus Q, if you introduce a dielectric, this will create minus Qi and this will create Qi. The force between the plates is independent of the slab. Because the slab has same plus and minus Q, does not create any field outside. So it will be the same as force in vacuum, which is Q square by 2A epsilon. So be careful, I should not write epsilon m in the denominator. This is not epsilon medium. So Q remained same, so the force will remain same. Because most people think that epsilon became epsilon naught, na? But you're forgetting something. That slab, if you see here, that's, the question is force between the plates, and the slab is not going to exert any force on each of this plate. Minus and plus will cancel out. Energy is half CV square. Capacitance became, I can use Q square by 2C, that is better. So C became Kc, so this becomes 1 by K times. Energy density is half epsilon medium E square. Here epsilon m aayega. Epsilon m becomes K times. Field becomes 1 by K ka square. So this is 1 by K times. You getting the catch? Energy density में that epsilon is epsilon m, but force में epsilon naught is not epsilon m. That's the thing you have to be careful. Do you guys remember the statement force between two charges is independent of the medium? The force between the plates doesn't change. Even if they ask you the net force on each plate, it still doesn't change because the slab is not going to exert any force. Is that clear? Now can you do case 2? Try. I'll give another minute for that. Case 2. Now the battery is there. Dielectric is introduced. Any doubts on this thing, please ask me. If you had submerged the plates in a medium of dielectric, will the net force change? Then the net force would change. Because I think then you'll start getting medium, charges outside also here. These things will affect the problem. Here,
Okay.
because it is inside, that is not affecting. But if you keep medium on both the sides, see, this plus will create minus here, it will also create minus here, na? This minus will attract this. So then overall net force will decrease.
Okay, so that's why, like in electrostatics, it actually had a difference.
Because there the whole thing was dipped in a medium. Here it's only partially, only in the middle was filled with a medium.
Okay, so
If you remember, that statement also wrote, the force becomes 1 by K times on the charge if the whole space is filled with medium. The charges should be inside. The second one, everyone. What if the battery is there? Let's say. So in this case, the voltage remains same. Capacitance becomes Kc, charge becomes K times, field becomes V by D, remains same. The force is Q square by 2A epsilon. Again, same story. You don't mess with that epsilon here. So this becomes K square times. Energy is half K CV square. K times. Energy density is half epsilon M E square. The field didn't change. So this is also K times. Clear with this? Just be careful with the force between the plates, one thing. There you won't get an epsilon there. All clear with this? Next one. So if we have two parallel plates connected by a battery, then what you did, you introduced a dielectric slab partially into this. Let this distance be x. Let me show you the, in 3D, the picture would have looked like this. You guys are able to visualize how it is? So that part is gone inside actually. So this distance was x. Let this be breadth b. Let this be length L. That means here L minus x is, this is the L minus x. Okay, and the length of the slab is also L only. The dielectric slab ka length is also L. Distance between the plates is d. So what actually happens is, if you actually look at the picture, see, the charges are induced on the metallic plate plus, and you have an induced charge here minus. Now, when you put a slab inside, on this slab, you have induced charges opposite ones here minus, and this is plus. So these charges get attracted towards this plate like this. Can you see how they're getting attracted at an angle? This creates a force. So this force is responsible for pulling the plate inside. So the moment you keep a dielectric slab, it gets pulled inside between the plates. Is that making sense? So the force between charges on the plate induced charges on the dielectric. Actually, no, there is a better way of even saying this. This is actually due to the fringe field. If you actually look at the plates, do you guys remember when you go to the edge of the plates, the field is not proper anymore. The field looks something like this. The filaments are coming, at an angle like this. So in this, if you keep a slab, remember this is negative. So this negative charge here will get attracted this way, no force. And this positive charges here will have force like this. Is that making sense? So the force is actually coming due to the fringe field. That is the actual reason. It's not due to the whole thing in the inside. So even though we ignored the fringe field in the beginning, for the purpose sake, the fringe field is the one who is responsible for pulling that slab inside. Making sense? So the question is, so this is the whole story, the picture and everything. Find the C equivalent, find the energy stored, and find the force on the slab as function of x. X is the distance the slab is inside. Find time period for one oscillation. If you release the slab from the starting point, find the time period. X is the length of the slab, length of the dielectric inside the plates. This thing is a side view, and that is the thing. I think this picture is understood. Let's get this. The result of the force is quite important, actually. That is a proper straightforward question I've seen a few times. Find the force on the slab. That's it. If you know the result, you got the answer. Let's finish off. That's the last one for the day. We'll wrap it up. I know people have major test. The C equivalent is easy, right? If you look at the whole capacitor, this part is inside. This was X. This was L minus X. You can simply treat them as two capacitors. Both are in parallel. This area will be, what was the area? That was B. This area was Bx. This area was B into L minus X. So this will be area Bx, K epsilon by distance is D. This guy is B into L minus X epsilon by D. Both are in parallel, so C equivalent will be, add them up, B epsilon by D L minus X plus Kx. What is the energy stored? Half C equivalent V square. B epsilon by 2D V square L plus X into K minus 1. Anyone remember the relation between force and energy? Minus du by dx. There you get everything in an order. So keep the process. If you find C equivalent, you'll get energy, you'll get the force, you'll get everything. Differentiate this and you'll get minus B epsilon V square by 2D into K minus 1. And the best part about this is a constant force. You should definitely mark up this result. The force on a slab is this. If it is a square plate, B will be equal to L. So the force actually depends on the breadth and not the length of the capacitor. Have a look at this. Quite an important result. And the best thing about this result is it's constant and the negative sign indicates attraction. And it kind of makes sense why it is constant. You know why? Think about it. Once the slab has gone inside, this positive and negative will attract this way. This negative will attract positive this way. This force and this force will cancel. No? If the slab is entered inside, the field becomes parallel, isn't it? These negative charges will attract upward and these positive charges will attract downward. These forces will cancel off. So the force is coming only due to the fringe field, isn't it? And fringe field ka this region is always constant. That's why you're always getting a constant force of attraction inward. So it doesn't matter how much the slab has gone inside. Whether the slab is little inside or the slab is completely, almost there, the force is constant. Clear with this. Now the second part of the question, time period. Most people think it is SHM. For SHM, force should be proportional to X. Here force is constant. This is not SHM. This is a periodic motion. Any doubts on this page, please ask me. So once you got this, you're done actually. So this is the slab. So when the slab is inside, this is the force. We know F is equal to mass into acceleration, and then we know L is equal to half AT square. Initial speed is 0. So from here we'll get time T is equal to root over 2L by A. This is not the answer. So when T is equal to 0, your slab is like this. The force is inward. When time is equal to T, the slab would have been gone completely inside at this point. At this point, you have a maximum speed, mean position. At time is equal to 2T, the slab would come out from the other side. Now the force of attraction will be inward. T is equal to 3T, the slab would again go inside. This time you'll have a maximum speed on the other side. And t is equal to 4t, you again come back to the same position. Therefore, time period is 4 times small t. This is a periodic motion. It's not an SHM. So they can ask you that, what kind of motion does the slab execute? People will let SHM and come. Because the moment you hear the word oscillation, that is the first thing everyone gets it. Are the steps clear, everyone? It's a pretty good question, pretty good result. There is one more standard question on this. The question goes like this. There are two parallel plates. So on this, once you get the force, you can bring your full mechanics. Parallel plates are placed just above the liquid surface. So there was some liquid here whose dielectric constant is K and density is rho. So you placed it just above the surface. So what happened? This force started attracting the liquid, and the liquid started rising between the plates. It's also like a dielectric slab, right? So the question was this: find the height of this liquid. Let the distance between them be d, and let the length of the slab be L. What do you think we should do? What was the catch? The dielectric of force F will be equal to mg, isn't it? That's it. That is the only thing. Straightforward mains level question. So force would be length epsilon v square by 2d into k minus 1. Mg will be density, length, height, width into g. From here you get the height. So once you get the force, you can bring all those kind of questions. Any doubts on this? It's a good one. Do check it out. It's an easy proof. Is that clear, everyone? There, anyway, that is also the last problem in capacitors. With that, we are done with the chapter. So definitely make sure to go through the entire notes. We have done almost 34 questions, series, parallel, capacitance, everything. Next class, when we catch up, we'll start with current electricity. Again, you'll see capacitors. Don't worry, it is not gone. You will now see current way. You will find everything in Gauss law, everything in capacitors, everything will pop up again. So next chapter will be current electricity. That's again another pretty high weighted chapter. Right. So we'll start off that on Monday and we'll continue with that. That's also a good thing. We'll have circuits and a lot of stuff. Like I keep saying, whatever portion we still have left as a good weightage. So please start solving parallelly with me. Now capacitors is over today. Try to finish all this at least by next Friday. Getting it week to week, try to finish it off. If you can't solve all your material